Hello and welcome to this lesson about basics of computing. This time we are going to study subroutines, and to study subroutines we are going to study what is a thing called a stack in programming, and then we are going to study the use of the stack pointer register in the imaginary computer, and we are going to study two new machine instructions. One instruction is called subroutine. 8.1 is that the machine instruction code for that, and then the other instruction is return to calling program. 8.2 is the machine instruction code for that instruction. My name is Kari Laitinen, and let's go to naturalprogramming.com. So from there, through this link you will find the IC8 start page, and from that page you can open the simulator. And I have here, I will load one program to the main memory of the simulator, and the name of the program is AAAABBBBCCCC.iml. So now you can see that the program is loaded in the main memory, and I will execute it very fast. We will study it later on more accurately. So I will execute it very fast, and you can see that it prints the letters 3 times A's, 4 A's, 4 B's, and then 4 C letters. So very simple program, and I have actually opened this program, or I have opened the IML version of the program into this editor. So this is the IML version of the program, and you can find this file AAAABBBBCCCC.iml. You can find it if you go to the start page, and there is a small link here somewhere. It's a small link to a folder where you can find all the IML files. So IML is the language, very simple programming language that we studied in the last video or the previous video, and now we are going to study also this program by studying the IML source code. So you can, here is the source code of the program, and well, all these lines that start with a double slash character, they are comment lines, and they are not actually, they don't actually belong to the program. They are just explanations, and here is the beginning of the program. So this name marks the beginning of the program. Actually, this name is not used in the program elsewhere, so it is not even necessary here. And then there are the machine instructions. So the first instruction is load register A with value, and this loads the value or the character code of lowercase a to the register A. And then there is this new instruction named call subroutine. So this call subroutine, and there is an address here. So this is the address name, and the address is here. So what this instruction means, that the execution of the program will go to this address. So after this instruction, the next instruction that will be executed is the first instruction of this subroutine. So this whole thing here is now the subroutine. So after this instruction, all the instructions of this subroutine will be executed. So, and this means now that output, so there is 4 times repeated this output byte from register A. So it means that the letter A, the lowercase letter A, will be printed to the screen, and then there is the instruction return to calling program. And what happens here is that when this instruction is executed, the program control will return to the main program, so we can call this part of the program, we can call this as the main program. And so when this was executed, so after this subroutine is executed, the program control returns to the following instruction that follows the call subroutine instruction. So after this instruction, the following instruction will be this one. So that increments the content of register A by 1, and then it again calls this subroutine. And again, all these instructions will be executed. And then the program control returns to the following instruction in the main program. And again, there is this increment register A there. So when the register A is incremented by 1, it means that, as we have seen, the character codes are such that sorry, from page. So here are the character codes. So for instance, the character code of lowercase b is 1 larger than the character code of lowercase a, and character code of lowercase c has the next character code. So so when the value of register A is incremented, the character that will be printed is first it is B and then it is C. So this call subroutine instruction, it means that the program execution jumps to this address here, and then all the instructions are executed until this instruction is found, and this returns the control to the following instruction in the main program. And eventually the control after this subroutine call is executed, the control returns to this instruction, and the whole program terminates, or the processor stops working. So let's see how this works in machine level. So we are now using 2 new instructions here. We can actually check the instructions. So the one instruction is 8.1 and the other instruction is 8.2. And here is a long explanation how these instructions work. So they are quite complicated, but we can most easily find this out how they actually work when we run the program with the simulator. And now it is very important also that, or let's reset the thing first. So we have the program already loaded into the main memory, and we are going to use these instructions, these new instructions, they are using this register stack pointer. So stack is an area in computer or in the computer main memory that is used for special purposes. And the stack works so that when you put something on top of the stack, and when you take something from top of the stack, you always take that value that is last put to the stack. And now the value of stack pointer is is FF. It means that it refers to the last memory location in the main memory. Let's see how this works. So I'll hit the execute button. So it starts from the beginning. It loads the first instruction 1.5, and that needs an operand. The operand is 6.1. So this is the load register A with value. So the character code of lowercase a is put to register A, and now it fetches the next instruction. So it is 8.1, and that is odd, so it needs an operand. And the operand is OB. So now the instruction is fetched, and it's already started to execute the instruction. It is important to know that this instruction code, so the called subroutine instruction has this 8.1 code, and now the address of the subroutine is now 0B or OB. And what it does here, the simulator, it first stores the return address to stack. Let's see what happens. So what it did now, it put the return address 04 to the stack. So 04 is now the address of this instruction increment, the instruction that follows the call subroutine instruction. There was some strange value in the last memory location in this in the main memory. It should have been FF, but there was, for some reason, there was some different value. And so now this is now the address of this instruction is now in the stack, and it decrements the stack pointer by 1. And now it moves the value, the operand value 0B or OB to the program pointer, and this 0B was the is the address represented by this name. So what happens now, that the next instruction that will be fetched, it is this instruction in the address 0B. And now it was the instruction 9.2 that outputs the content of register A. And so there are altogether 4 of these 9.2 instructions there, and they all output the same character to the screen. And again it fetches the instruction 9.2, so there are 4 of those. And the letter A is printed 4 times. So now it's fetching the last instruction of the subroutine, and now it is the 8.2 instruction. And now it starts executing the 8.2 instruction, and then it does the opposite thing as the other instruction, so that it now takes the return address from the stack, or the address that was following the subroutine call. It takes it from the stack. Let's see what happens. It first increments the stack pointer, and now it reads the return address from stack. And the return address is 04, and it takes that as the value of the program pointer. So now the instruction return to calling program is executed, and now it fetches the next instruction, and that is in address 04. And it increments the register A by 1, and it fetches the next instruction, and that is again the 8.1. And that needs an operand, which is OB or 0B, which is the address of the subroutine. Now it stores the return address to stack, so it takes the value of program pointer and puts that to the stack. And it decrements the stack pointer as well. But yeah, now you can see that it put the value 07 to the stack. So that is the address of this instruction. So the previous value was 04, so that was the address of this instruction. So it decrements the stack pointer and it moves 0B to program pointer, which means that the subroutine is going to be executed. And now it outputs the letter B, lowercase letter b, 4 times. So you can see there that there is this output byte from register A. There are 4 of these instructions there, and the last instruction is then 8.2. So now it's going to fetch the instruction 8.2. That is the return to calling program instruction. And now when that is executed, it takes the return address from the stack that was put there earlier, and its value is 07, and that is moved to program pointer. And with this operation, the now return to calling program takes place. So now this instruction is being executed, and now the register A gets the value 63, and again it fetches this instruction, and then it fetches the operand, which is this. So it's 0b is the first byte of the subroutine. You can see that it is in the location 0b. And it puts the return address to the stack, and now the return address is 0a. So it's actually the address of this instruction. And now again it executes these 9-2 instructions 4 times. So I will just, because you remember that in this simulator program you can, if you click some memory location here, it will execute with full speed until that location. So I will now hit the instruction 8-2, so it will execute full speed until that, and then it goes with a slower speed. So it took the return to calling program instruction from the main memory, and it reads the return address from stack. And now the address is 0a, and that is the address of this stop processing instruction. So now the program is executed and the processor stopped. So you may wonder that why this thing called stack is used for the subroutine calls, but the secret for that is that when we are using the stack, it will be possible to make such programs that one subroutine calls another subroutine and so on. And when all these addresses, when they are put to the stack, the return addresses can be found in right order. So the stack, you can think of a stack that it is like because the last, or you can think of the main memory like this, that there are a lot of locations, and the last part of the memory is used as the stack. So it means that you can always put more values into the stack, and you can then always, when you take one value from the stack, you always take the value that is the last one put to the stack. And we can actually demonstrate this, or I can demonstrate this so that I will modify this program a little bit. I will modify it so that I will let's modify it so that I will write another subroutine here, and let's say it So I will make this program such that it will always, when it has printed 4 times a letter or the content of register A, it will always then print a space character after that. And I will, because I can't modify the register A here, so I will use the register B there. So there should be an instruction called load register B with value. And when I'm using this, when I'm writing like this, it puts the space character code of the space character into the register B. And then I can use this other instruction, output byte from register B, and when I can then call this other subroutine from here, like this. Like this. So now always when it calls this subroutine, it first outputs register A 4 times, and then in the end it calls another subroutine output space character, and then it goes here, and then the space character is output to the screen, and then it will return to following instruction of this, which is this, and then it will return to the main program. So I will save it and I will now compile it. You can probably remember that I have this file. I will first change to documents folder, and then I will change to the IML directory or folder, and there I have this A, B, 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 C, 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 and now I'm going to compile it. So the compiler works like this, that imlmac.up is the name of the compiler, and I'm going to compile now this file. And again I can check that now there is this A, B, 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 C, 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 C dot ICE, which is the result of the compilation. And now I can check the content type. Sorry, I will use the more command here. More, like this. So this is now the executable code of the new version of the program. So we can, if we check it with the simulator, because on purpose I modified only the last bytes of the new program, so I have to modify only those bytes that come after these 4. So I have to modify only those bytes that come after these 4 instructions. So let's modify the code in the main memory. So after 9.2 comes 12. Sorry, it comes 8.1, and then there is 1.2. So this is the address of the new subroutine, and then there is the 8.2, and then there is the 1.7. So this is load register B with value, and this is now 2.0. That is the character code of space character. and then we have 9 I have to redo this. 9 4, it's the output byte from register B, and then I will put here the 8 2, which is the return to calling program. So now I have modified the end of this program, and now it should always print a space character after it has repeated one character. So let's try it. So I will reset the processor and I will execute it. So it again starts from the beginning. So I will put a little bit more speed there. So now it is the load register A with value. I had to lessen the speed. So now it is calling this output register A 4 times, and it puts the return address to the stack. So it's again, its address is 04. And now it starts executing these instructions of the original subroutine. So you can see that it always, it's quite dull thing when the computer operates, so that it always now loads the same value, 92 from the main memory. So now it is the third A character that is going to be printed. So, and now it is the last A character, and now it should execute or fetch this instruction, which is again the 81 instruction, and it needs now an operand. And now the operand is 122, so it is this address, or the address represented by that name. And now you can see that the stack is now used more than one time, or there will be 2 return values in the stack. So now there is, so I will stop this for a while. So now you can see that there are 2 values. There is value 04 and value 11. So it means the value 11 is the address of the first return address, which is this one, and the 04 is the other return address, which is the address of this instruction. So let's see how it works. So then now the register B is modified. Now it fetches the 84 instruction, so it is this instruction. Now it prints the space character, but we can't see much on the screen. And now it fetches this instruction. It increments the stack pointer and reads the return address from stack. And that address is 11, and it is copied to program pointer 11011. Now the next instruction is that the instruction in address 11, and it is now the address of this instruction. And now it again increments the stack pointer, and it takes the last value away from stack. And it moves the 04 to program pointer, and now it is the address of this instruction. So I think I will now put this to the full speed so we can see the result. That indeed, after all, always when some letter is printed 4 times, then there is the space character after that letter, and that is done by this new subroutine that we added to the program. And so the key idea in the use of these subroutines is that we use the stack, and so in that way we could have really very many subroutines in our programs, and always there would be a correct return procedure to the calling routine. And these subroutines, I think it's quite important that you can understand that how these subroutine calls, when they take place on machine level. So it is important to know that there is such a thing as stack, which is used for this purpose, and these stacks are also in use in real processors, not just only in these imaginary processors. And when you use higher level programming languages, you will be using things like functions and methods, or maybe you can use procedures. So these are also subroutine calls, and they are translated to these instructions like we have in this imaginary computer, like this call subroutine and return to calling program instructions. So I think this is subroutines are very important thing in computing, and I hope you enjoyed this video. And I think if you didn't understand everything, you should play with the imaginary computer simulator, the IC8 simulator, and you could yourself write a new subroutine to do something, for instance, in this program. Well, I thank you for your attention, and we will still meet in some other video. So thank you and bye.